All right, guys, welcome back. We are starting a new unit here with Unit 3. So this is going to be talking primarily about triangles here for the entirety of this unit. Now, for some of you that did the Khan Academy stuff a couple weeks ago, this is going to be almost a review if you did a lot of these things. Otherwise, it's going to be kind of pushing those standards to you guys in a little bit more creative way here, in terms of getting you to extend your thinking a little bit more and just understanding those properties of triangles and determining whether they're similar, congruent, and what have you. So these are the three standards, F, G, and H. You can read them yourself. I'm not going to go through. But we are going to be talking about triangles and some of the classifications that go with them, okay? So this unit is going to be calling on some of your information regarding triangles and then applying some new information as well. So the first section we're going to start is 4.1. Now, I really want to make sure, guys, that you understand that this unit is not like one chapter, okay? So this is going to be going from two sections in Chapter 4, one from Chapter 5, and then a bunch from Chapter 6. So it kind of jumps over around a little bit. So if you're wondering why we're going from Chapter 4 to Chapter 5, Chapter 6, that's because we are kind of classifying them by standards, not necessarily by the chapters in the textbook, okay? So just follow along, bear with me as best you can, and we will do as much as we can get through here, and then we'll start doing some Google Form actual assessments here. I can push those out to you guys to see what you're doing in terms of some of these questions. Okay, so section 4.1 is I can identify different types of triangles by angles and sides. So this is applying triangle sum properties. This is what this section is called, applying triangle sum properties. So we're going to go over some things by just reviewing how to classify triangles. So there's two ways we can classify triangles, by their sides or by their angles. So if you guys remember a little bit from the first I think we talked about triangles a little bit, maybe not. But if we didn't, we can talk about classifying triangles by their sides. So we have three types that we can classify it by. Scalene, isosceles, and equilateral. Okay? A scalene triangle is one that does not have any congruent sides. Okay? So a scalene triangle is one that all the sides are different lengths and there's nothing that is in common or the same in terms of their side lengths. Okay, so they're all different sides. An isosceles triangle has at least two congruent sides. Okay, so at least two congruent sides. And then an equilateral triangle, obviously, as you guys could probably tell here, I think we did talk about this early on when we were classifying polygons, but an equilateral triangle then is all sides are congruent. Okay? So those are the three classifications that we can deal with in terms of side lengths. Now, when we talk about angles of triangles, okay, an acute triangle has three angles less than 90 degrees. So that means all three angles are less than 90 degrees. An obtuse triangle has one angle that is greater than 90 degrees. Okay? So not all three, obviously that wouldn't be possible as long as one angle is, I'm going to reiterate and say this is all three angles. Okay, only one angle is greater than 90 degrees, the rest would be acute. A right triangle, you guys should know that. One angle is equal to 90 degrees, so this would be if we had that right triangle symbol. And then an equiangular is all congruent angles. Okay, so again, we classify triangles by their sides and by their angles. Okay, so an acute, obtuse, right, equiangular, and then a scalene, isosceles, and equilateral triangle. So just going over, making sure that we understand what those classifications are before we move on. Okay, so it says find all the angle measurements and classify the triangle by its angles. So what this is asking us to do is we need to figure out what the individual angle measures are, and then we were going to classify them by their angles given. Okay, so we know that the sum of the interior angles of a triangle must add up to 180 degrees. So what this is saying is all three of these angles must add up to 180 degrees. So with that, we can then say that the sum of these expressions that represent the angles must also equal 180 as well. So what we can do is solve this here. So we can combine our like terms. So we have 6 plus 4 plus 5x. Okay, so that would give us 15x. And then we have negative 12 and a positive 12, which just makes 0. So we have 180. We will divide this by 15. Okay, and if we do that, we should get x is equal to 12. All right. So if x is 12, we're now going to plug these in to find what that would be. So this would be 6 times 12 minus 12. So 6 times 12 minus 12 is 60. Okay, so this one is 60. We've got 4 times 12, which is 48, plus 12. That one's also 60. So I'm going to just make sure we can see that. So 60 here, and this one goes up there. And then 5 times 12 is 60 degrees as well. So this one also equals 60 degrees. So we have all the angles being the same. So it says classify the triangle by its angles. So since they're all equal, so we have 60, 60, 60, this is an equiangular, that's not right. Angular triangle. Okay, so we have an equiangular triangle here given those measurements. So again, we knew that we could add up all the sides here to have them equal 180. We solved for x and then plugged them back in to find the angle measures given those expressions. Okay, if that went too fast, just go back, rewatch. Otherwise, please feel free to let me know if you have any questions. Okay, so now it says find all the angle measures and classify. So it's the same thing. I want you guys to try this one on your own. Pause it, and then we'll come back and answer. All right, so hopefully you paused and you were able to figure this out. The one thing I want you to note here is this is not drawn to scale. So do not assume that because it looks like it's maybe one type of triangle that it's necessarily going to be. So we're going to do the same thing we did before. We have the sum of three angles must equal 180. So we have 3x plus 40 plus 2x plus 40 again, and that has to equal 180 degrees. So we'll add our like terms together. So we have 5x and then 40 plus 40, which would be 80, equals 180. I subtract 5x equals 100. So x must equal 20. Okay? So we have x is equal to 20. Now we got to plug them back in. Okay? So let's go here with this angle. So we've got 2 times 20. So this is going to be 40 degrees as well. And then we'll do that here. Okay? So this is going to be 3 times 20 plus 40. So this is 60 plus 40, which is equal to 100 degrees. Okay? So we have two angles that are congruent. Okay? And we only have one that is not. But the sum does equal 180. So for classifying it by its angles, we have four choices again here. We have acute, a right angle, an obtuse, or three congruent. And since we have one obtuse angle, this is an obtuse triangle. Okay? Again, we're classifying by angles. Just make sure you're reading the directions as far as what it's asking you guys to do. So you would make sure that you find all those angle measures. So we've got 40, 40, 100, and then a classification by its angle. All right? The next thing. Now, we have a diagram here. So what we have here is we have a obtuse triangle. We have one angle that's greater than 90 degrees, but we also have a line extending out from one side to create another angle. Okay, so it actually makes a linear pair. So we see that we've got this line that's cutting right here, and here. So we know that if it's a straight angle, the sum must be 180 degrees. So that's where that 80 comes from, okay? What are some things that you notice, though, about the other angles in this triangle, okay? So we know that these two here have to equal 180, but do you notice any other relationship between that 80 degrees and the other two angles in the triangle? If you did notice, the sum of these two is actually equal to what, or not the sum, I guess these aren't congruent. I don't want to make sure, I don't want to confuse you guys here, but the sum of 20 plus 60 equals 80, and that is equivalent to this angle right here, okay? Now, is that a coincidence? Is it just happenstance? Well, to be honest with you guys, it's actually something that we call the exterior angle theorem, okay? So this is a theorem that basically states that if you have one exterior angle, the opposite, or in other words, non-adjacent interior angles is going to end up being the same. If you add those up, that will equal that exterior angle. So for example, as you see in the board here, we have a exterior angle, measure of angle 1. The opposite, or the non-adjacent interior angles, A and B, the sum of them has to equal the same. Because if you guys think about it, we know that these two angles have to be 180 degrees, okay? So whatever this section is here, whatever this angle is, okay, whatever's left is going to be 180 minus this angle here, right? Because we're taking away one angle from the total 180. So whatever's left has to be this. But if we know that these two, okay, if we know that these two have to be the sum to make that 90 or that 180 degrees, the remaining then would also have to have the same relationship with this exterior angle here. Now I know that might not have been the best explanation, but as long as you understand that the sum of angles A and B equal that exterior angle 1 here, that's all you really need to know. And I'll show you what I mean when we go through some examples, okay? So it says find the value of x, classify the triangle by its sides and angle. So we're going to classify it two ways this time. Now, we're only given two of the interior angles, but they are actually the non-adjacent angles to that exterior angle, okay? So we have 5x plus 20. Based on that theorem, that exterior angle theorem, we can state that 5x plus 20 is equal to x plus 15 plus 3x plus 23. Because again, guys, that interior angle here, I'm going to label as 1 here. If we add all three of the interior angles up, that has to equal 180. We also know that that straight angle right here also has to be 180. So by the transitive property, we're basically saying that that 5x plus 20 must equal the sum of those other two angles, because of the fact that they both have to add up with that interior angle to be 180. So now all we have to do is solve this equation like we have any other one. So we've got 5x plus 20 on this side. That's going to say the same. Let's combine our like terms. So we got 4x and plus 38. Okay, so we will subtract 4x from both sides and then subtract 20 from both sides. So we're going to get x is equal to 18. Okay, so now we need to see if we can figure out what those angles are. So for this one, we're going to have 18 plus 15, and that is going to equal 18 plus 15 is 33 degrees. Okay, this guy right here, we're going to do 3 times 18 plus 23. So 3 times 18 is 54, plus 23 is 77. This is going to be 77 degrees. And then to figure out the rest, if we do 77 plus 33, we get 110, and then 180 minus 110. So this guy right here is going to be 70 degrees. So if we classify this by its sides, this would be a scalene triangle here, because we don't have any confirmed equal angles. So this is going to be a scalene triangle. And then if we classify it by its angles, we don't have any congruent angles here. We don't have any obtuse. We don't have any right angles. And we have 3 acute though. So this is a scalene acute triangle, okay? We don't have any side lengths that are confirmed to be congruent. And actually, guys, if you, we're going to talk some more about some angle relationships later, but since we don't have any angles that are the same, there's no way that we have any congruent sides. There is a relationship between the angle measures and its side lengths in terms of whether they're congruent or not, okay? As far as that example goes, that should be good enough there. As far as any explanations, again, if you have any questions, please feel free to shoot me an email. Why don't you guys practice and pause here, and you can try this one on your own. Just a quick note before you pause, the homework is split up into 2 days. So if you were to stop, try to figure out what the homework is, this would be a good place to stop. There's really not going to be that much left after this. It's just more to segment the homework and break it up so you guys can not feel so overwhelmed with that. And the second day is more of applying some higher level thinking, kind of like proficient advanced problems, okay? So let's practice. Again, this is the same. So we have 2 interiors that are non-adjacent to that exterior. So we could do x plus 45 equals 2x minus 2. So we can solve for x. So I'm going to subtract an x from both sides, add 2. So I get 47 is equal to x. So that would mean I have this angle here where x is going to be 47 degrees. So if I do 45 plus 47 and minus 180, that should give me 88 degrees right here, okay? Since we don't have any congruence, so this is going to be a scalene acute triangle as well, okay? All those side lengths are non-congruent because we don't have any congruent angles as well. So therefore, and none of the angles are greater than 90 degrees, so this would give us a acute triangle. So hopefully that made sense for you guys there. And then the last one we're going to go over is an example of a proficient problem you might see in an assessment. And what I'm going to start doing, guys, is after we get to our regular assessment portions of our units, I'm just going to post a Google form of the assessment. I want you guys to try it out on your own, okay? And I'll grade it for you guys and see how you guys did, okay? So it says find the value of x and y. So we have 2 triangles here formed by, looks like 2 lines intersecting and then closing them off here, okay? So what we're going to do is we're going to use some theorems here. So right now, we can say that this angle here and this angle here are 2 non-adjacent angles to this guy right here, okay? So what we're going to do is we're going to do just what we did before, okay, to try to find out what x is. So we've got 38 plus 7x plus 1 is equal to 10x plus 9. So let's start solving for x. Okay, so I'm going to combine my like terms. So I have 7x plus 39 is equal to 10x plus 9. So I'm going to subtract a 7x from both sides, subtract a 9. So I'm going to get 30 equals 3x divided by 3. So x is going to equal 10. All right, so there's our first part. Now we're going to find out what y is. Since we know that these 2 are a linear pair, that means their sum is also going to be 180 degrees. So we're going to plug in that value for x to find out what our y is. So we've got 10 times 10 plus 9. So we're going to get 100 plus 9, and that equals 109. So to find the measure of y, so y is going to equal 180 minus 109. And that is going to give me an answer of 71. Okay, so our answers here, we should have got x equals 10 and y equals 71. That was a pretty quick example, guys, as far as what you need to know for x. But as long as you guys are following along here and you were able to make sense of that example, this should have been a relatively straightforward section for you. So hopefully this is a good introductory, guys, as far as what we're going to be doing in the next unit. Again, if you need to watch the video back again, please let me know. Hope you guys have a good rest of your day. Again, homework is broken up into 2 days, and you can split that up. You can see it on the checklist. Okay, have a great day, guys.